You're still here? Wow, you managed to sit through that riveting history lesson in the last episode. Good. I'm glad you're still here. So now we're going to write our first program. First program is called Helloworld. This is somewhat of a tradition in the programming world. It's because all we're going to do is print out Helloworld. I'm not exactly sure where it began, but every programming course on the planet does it. It's cheesy, but I think we've got to do it, Let's get started. So go ahead and turn your computer on and fire up a terminal. Now we're going to examine the terminal and see what compiler is available. You should have GCC or Clang. So first of all, type Clang and see if you've got that. You got that? Okay. What about GCC? Type that. It might have a postfix on it. Like on this FreeBSD system, it says GCC 48 because it's GCC version 4.8, and they want to distinguish that from other versions that might be on the system. So you've got a compiler, you've got your terminal. You also need a text editor because we need to be able to edit our program. So find a text editor, your favorite text editor. If you're familiar with Unix and so on, you'll know what that is. Otherwise, if you were one of those poor unfortunate souls who went and installed it, well, look for, if you're on KDE, look for Kate, or look for something like Mousepad on XFCE, or Gedit, I think on GNOME, and it'll probably be in the menu somewhere. You'll find a text editor, they all come with one. So let's take a quick look at these. So look there. So this is Mousepad, this is Kate, and this is Gedit. They look pretty similar, right? Now the beauty of all of these very simple editors that you're bound to have on your system, is that they include syntax highlighting. So on Mousepad, if I set the file type to source C, you see that now certain things are highlighted. This is really handy. And I can do the same on Kate. So by going to settings, tools, highlighting, source, see, there we go. And look, this is also highlighting brackets, which is nice. And also on Gedit, we can go to View, Highlight Mode, C. There we go. So syntax highlighting is a really important thing to have, a really useful thing to have. It will help a lot in understanding the distinction between the various aspects of a program. Right, got your text editor? You got your terminal? You got your fingers? Let's go. First of all, open up a terminal. I've made the text on this terminal massive so that it shows up on the YouTube video well. Please let me know what you think about that, whether or not the text is too big or too small. I don't know how it's going to be received, so please let me know. The first thing we want to do is create a directory for this tutorial series. So type mkdir, make directory, c_tutorials. And then cd to change directory into c tutorials. If we type ls to list files, there's no files in there because we haven't created any. I don't know what your prior background is. I'm assuming you have Linux background, but I don't know. So if this is your first time in the terminal, you might be thinking, oh God, what are all these commands? Well, you're going to learn about these commands as well in that case. And for further information about any command, what you can do is type man, which is brings up a manual, and then for a command like make directory, and then hit enter, and then it will bring up the manual page for that command. So the mkdir utility creates the directories named as operands. So it just creates directories, and there's all kind of options you can have for it, and you can read all about the options. So that's man. It's a very useful command for beginners, and you can learn all about the operating system. On FreeBSD, you can actually even do man intro, and it will tell you all about FreeBSD, which is very nice. It's a good starting position. Anyway, so you've got a terminal up and running. What you also need is your text editor. So assuming it was mousepad, fire that up. You can also fire it up from the command line if you know what you're doing. And you want to create a new file. Oh, there's already one created. So let's just save this file in our directory, C tutorials, and we're going to call it helloworld.c. And if we look now at our terminal and type ls to list files, we can see that helloworld.c is there. And the way that this is going to work is we're going to make edits in our text editor, we're going to save it, and then we're going to go back to the terminal and type commands, and then they're going to operate on the latest saved file. So that's why we have both open, the text editor and the command line. Now, in this tutorial and in the future tutorials, I'm not going to use any of the text editors that I recommended for beginners. I'm going to use Vim, because Vim is my favorite text editor. So I'm actually going to do that on the command line. I'll just show you what the setup's going to look like so that you're familiar with it. First of all, I'm actually going to get rid of the title on the menu bar on this terminal, and I'm going to full screen it. I'm going to use a command called tmux, and I'm going to split my terminal in two, and I'm going to launch Vim to edit the file. So on the left pane here, this is my text editor, and essentially the right pane here is my terminal. I'm also going to create another terminal in the background, which I can switch to. I can just switch between these two, so that if I want to look at a man page, I can do that here. Okay, so I hope that's not confusing. Essentially, this is my text editor, and this is my terminal. As long as you can distinguish those two, everything will be fine. I hope I'm not being patronizing, but I really don't know what your current level is. After a few episodes, I guess we'll find the right level. So go back to your text editor and type in the following line. It's hash include angle bracket stdio.h close angle bracket, and save the file. Well, save it whenever you want. I tend to save quite often. Now, what this first line is doing is including a library called standard.io. H means header file. So in C, all the functions for a particular library will be described in a header file. You'll learn all about this in the future, but for now, all you need to know is that you're including this. And if we go, I'm going to open up go back to my other terminal, and our old friend man is very useful here again. So I can type man stdio, and it will, here we are, FreeBSD library functions manual, and I can look at the manual page for the standard input output library. And it will tell me all about the standard input output library and what functions it provides and so on. So there you go, man again being incredibly useful. Just make sure you use it and you can't really go far wrong. So go back to your text editor. So the reason we're including standard.io is because we want to print. And we need to include that to use a function called printf. But we're not quite there yet. The first thing we need to do is kind of write the wrapper around our program. Now this is going to look a little bit strange, but don't worry. So it's int main, open bracket, int argc, comma, char, asterisk, asterisk, argv, close bracket, open curly brace, and then closed curly brace. And what you'll notice in these text editors, in yours as well, and some of them, is that when you hover over a bracket, it highlights the other bracket. So this one has been highlighted. And if I hover over this one, it highlights this one. This is very useful, but also illustrates something about the programming language C. And this will be common to all programming languages. Things are always bounded by blocks. So our main function is this is a wrapper. What all this means, this wraps whatever we put in here, in between these two brackets. So these are the constraints of our program between these two curly brackets. And that's all you need to know about that at the moment. So if you want to play around writing different programs after you've written this one, printing things, just make sure that you include this line and you've got these curly braces. Now, programming languages are very finicky and precise. They do not forgive mistakes. So if you omit this closed bracket and try and compile the program, it won't work. I'll show you this in a second. And so programming languages are incredibly unforgiving when it comes to precise syntax. This is how they differ a hell of a lot from natural languages, where you can basically get away with saying things in a lot of different ways, and slurring and saying analogies and things like that, and you'll still be understood. With programming languages, you won't be understood. Right, so then the next line in our program is printf. Open bracket, and now we're calling a function called printf. If you want to know more about that function, go to your terminal and type man printf. And printf provides formatted output to the screen, because we're going to print to the screen. So go back to your text editor, and inside the printf function, so we're calling the printf function, and this open bracket here means that we're passing arguments to the printf function. I'm going to talk all about functions in a future episode, but let's just get ahead and write our first program. Type in whatever text you want. Hello world is the kind of classical string with an exclamation mark after it, and then we need to do \n for a new line, because it doesn't give you a new line. Printf doesn't give you a new line itself, and this is useful. Sometimes you might not want to print a new line, so you have to tell it that you want a new line, and this is called an escape character. And if you look in the printf manual, you can see all the things that all the kind of characters you can put in there, which can be escaped. You can put tabs in there by doing \t, but \n is going to give us a new line. And then we need to close off this call to this function. So that's the close bracket. And this is called a statement that was just written. And every statement needs to be closed by a semicolon. So at the end of every line in C, or every statement in C, you need a semicolon. So it's actually the end of every statement. You can put another statement here. We could put another printf statement here. But typically, the way that you write a program, usually you've only got one statement on each line anyway. What we also need to do is, well, we don't actually need to do it or compile without it, but what we should do is return 0. So our second statement is return 0. White space is ignored, so we can put as much white space in there as we want, and the compiler won't care. The reason we've got return 0 is on Unix and other operating systems, in POSIX it's specified that a program should return an error code, and 0 is used to mean that the program executed successfully. So we return 0 to indicate that. So that's it. So what our program will do, if we just look at that, all it's going to do, it's going to do everything between these two brackets, curly brackets. It's going to print hello world, and then it's going to return 0, and it's going to end. So it's just going to actually exit at that point. It's going to exit when it returns 0. So save that. We're now ready to actually compile your first program. So go to your terminal, and I just realized with this large font it's quite difficult to see. I can just rectify that by doing something. Don't worry about this. Okay, there we go. Type in the name of your compiler. So whichever one you had, Clang or GCC, type in Clang. The syntax will be the same for both of them. Then the name of the file, helloworld.c, and then we use a flag called -o. And this says specify the output file, or the object file that we're going to generate. And let's call it hello world. Now hit enter. We actually don't see any output there because everything is compiled perfectly well. But if we list the output, oh, I can now see that that's pretty terrible, isn't it? To have that large font. We'll change that in the next one. But there is your hello world in red. And to run it, you do /hello world to run that file. And now if you hit enter, there you go. Hello world. Congratulations, you've just written your first C program. And if you've just started programming, you've just written your first program. Nice one, man. Next, let's have a look at when things do not go well. Let's have a look how fragile programming is. Hello again. I've changed the layout of my screen so I've got more space on the terminal here on the right. Still got the editor on the left. Now, so you've written your first program and that's all great. And if you typed it out correctly, exactly as it is on the left, you would have seen the output that I showed on the right. And just to show that you can do this with GCC as well, let me just alias GCC to GCC48 so it looks the same. If I type GCC helloworld.c with an output of GCC world, let's say that, and I run GCC world, you'll see that that also works. So it doesn't matter if you're using GCC and I'm using Clang, don't worry about that. There's some minor differences. I personally prefer Clang. If you can install Clang on your package manager or whatever, I would recommend it. It's a very nice compiler and has nice colors and things like that. So let's have a look at when things go wrong. I said that C was an incredibly, well, and all programming languages in fact, are very unforgiving. Not all programming languages require a semicolon after every statement. Many of them use, such as Python and JavaScript, use new lines or just spaces. But in C, you do need a semicolon at the end of each line. So what happens if I delete that semicolon, save the file, and now run the same command as well? By the way, in order to compile this, you don't have to keep typing the same commands over and over again. If I press up, I can actually look through the history of things that I've just typed. So you can just press up and down to cycle through your command history on the command line. It's very useful so you don't have to keep typing this all out again. If we run now clang helloworld.c and hello world, the same command that we ran before, to compile our program to make it into an executable with our erroneous file, let's have a look what we get. Oh, so it says, Clang says helloworld.c 326. It's actually telling me that the error is on line 3, character 26, expected a semicolon after expression. One error. And that will not generate the program now. If there's any errors, the program will not be there. Just to show you that, if I run that again, there's no hello world in red. There's no program that's been generated. Just to show you what it would look like in GCC with the same error, because it's slightly different, it will say hello world in function main 5.2 error expected semicolon before return. So it's essentially the same errors given, but it's explained slightly differently. Clang actually has better error messages. That's why Clang is a kind of future compiler that is really nice actually. But even if you're using GCC, you're going to have to get used to error messages. And sometimes error messages can be incredibly cryptic. Sometimes you can't really understand what the problem is, especially when you have a large program with many kind of brackets, many different areas of scope as they're called. Then it can be quite difficult. You'll be looking at it and thinking, I can't see what's wrong, and you just have to keep playing around until you work out what's wrong. Programming requires quite a lot of persistence when you encounter bugs. But anyway, So that's what happens if you omit a semicolon. So that seems reasonably easy to rectify. We put the semicolon back in, compile our program again, and there's no problem there. We're back again. I'm just going to change this to hello errors. Let's have a look at a different error. Imagine if we typed printf wrong and we put print G instead. We just accidentally pressed G on the keyboard. Let's try and compile that and see what happens. Oh dear. Hello world, on line 3, character 2, it says warning, implicit declaration of function. Print G is invalid in C99. See, what's quite interesting here is that this is just a warning, it's not actually an error. But, because that's at the compilation stage, I'm not going to go into this today, but there are actually 2 stages to compiling. There's compilation and there's linking. In this case, we've failed at the linking stage, and it says here, in function main, so in our main function, undefined reference to print G, clang error, linker command failed with exit code 1. See what I was saying about exit codes? So its exit code was 1 to say that it failed. Use V to see invocation, so if we want more information we can pass in V. Now what this means is, undefined reference means it couldn't find the function printg. So first of all, the reason it said implicit declaration is because it couldn't find a declaration of that. In the header files, there will be declarations for all the functions that header file provides. They're kind of prototypes. And then when we use those functions, Clang knows that they're there because they're in the header files. It couldn't find print G. It doesn't exist in standard io.h. So what it was saying here is, oh, you're trying to implicitly declare the function. You're just using the function you're declaring it by using it, which is invalid in the C99 standard. So it's giving a warning. But Clang's allowing it to continue here. And we really only get our error at the linker stage when it tries to look for that function in the library and it can't find it. So it says undefined reference to print G. So that's what happens if you make a mistake and you try and call something that doesn't exist. It will also fail. Let's just have a look what GCC says as well. Let's clear the screen. So GCC doesn't warn us about the implicit declaration, but it gives us the same linker error, which is undefined reference to print G. LD returned 1. So LD is the linker that GCC uses. And that's essentially linking all the functions that you've used together into one executable. Don't worry, I will go into this in more detail in the future. But that's another common error that you'll see actually. When you're not linking correctly, you'll see undefined reference. I just thought it'd be useful to go through some errors so you can see them and you know how to correct them. So we know how to correct this. We obviously changed that back to printf. And now if we compile again, of course, everything is fine. We've got our hello errors coming out. Okay, let's try one more error. In the function printf, you have to pass the string that you want to print. This is called a string. It's a string of characters. You have to pass it within these inverted commas, or rabbit ears, or whatever you call them in your country or in your locality. So what happens if I get rid of one of these? Well, immediately you can actually see that the syntax highlighting's changed. And that's actually one of the reasons that syntax highlighting is so useful, because you can immediately pick up errors like that. But let's ignore that we can clearly tell by the syntax color changing, and we'll try and compile the thing anyway. And Clang is giving us a very helpful error. Missing terminating inverted comma character. Oh, not inverted comma, inverted commas character. Expected, and then we've got error expected expression. So that's a little bit cryptic, but it means it expected an expression within printf, within these 2 brackets. But it was useful enough for us and nice enough to us to tell us that we've got a missing terminating inverted comma. So we can easily fix that up by putting that back in. But before we do that, let's see what GCC says as well. Okay, in function main, warning, missing terminating inverted comma character. Oh, fantastic. So GCC is being very friendly as well here and giving us good information about what's going on. Expected error expression before return. See, what happens is the errors tend to cascade, and this is where it can become elusive when you're looking for an error. If you just see the sort of end ones, because there's a missing terminator at the end of our string, there's another error generated, which is then expected expression before return. And then there's another error, which is expected semicolon before the bracket, because the parser carries on and it continues to find further errors, because once the input stream is messed up, you get all these other errors, and that's where it can lead to a lot of confusion. All right, well, let's fix our program up. Change it again. It's useful to sometimes change what you're printing, just so you're absolutely sure that you're running your new program. So if I was just to run that, obviously not running my latest program, but if I compile the new one, let's just do it with GCC for the sake of it. And we've got hello fixed. There we go. Now, in the future tutorials, I'm going to stick to Clang, just because I like it, and hopefully you can get hold of Clang. If you're on Linux, you can definitely get Clang. If you're on FreeBSD, Clang's the default compiler. If you're running it in VirtualBox, you can look up how to use a package manager and install Clang, because I think it'd be good if we were both using Clang. But if you are using GCC, don't worry, your error messages will be slightly different, but there shouldn't be any differences otherwise. You can use them interchangeably, essentially. Well, that's it for episode 1. You've written your first program and your first C program to boot. I hope that was useful. If you've got any questions about the tutorial, please put them below. See you in the next episode.